Hi, I'm Chris.
And I'm Rick. Welcome to Inside Festool.
So Rick, you've been around for a few years. How long has Festool been doing circular saws for?
Well, you would think we just started with the plunge cut saws because that's what a lot of people know us for, what is called commonly now a track saw. But our history actually goes back to the 1930s. So we brought in this big beast here. Although it's not a track saw or a plunge cutting saw like we see today, we do have a long history of developing circular saws, circular saw blades, and overall cutting technology. So a little bit more about our history. I have put before you several samples on the front row of what we call our 55 size. It hasn't always been called the TS55. In fact, it was called when we first launched it here in, I guess it was the early 2000s, the ATF 55. This is probably the most common one that was seen for a fair number of years until we came to the TS55. So we had the TS55 EQ, then we had the TS55 REQ, and most recently, as of March of 2022, we have the TS55 FEQ. So I really want to just kind of drive home here. We have a whole evolution of change, always with the focus on cut quality, performance, and durability. And we don't just have the 55 size, and we don't just have track saws. We do have some other variations back here. Again, going back in our time machine, this is the AT65E. This was the predecessor to the 75. So a little bit bigger blade, a little greater depth of cut versus the 55. By the way, that indicates depth of cut, 55 millimeters off the rail. The rail takes about 5 millimeters, so it's 50 otherwise, or just under 2 inches. So the AT65 gave us a little bit more depth, but also has quite a bit more weight to it. And then it was replaced in the mid-2000s, 2006, 2007, somewhere in there, with the TS75. So it had greater depth of cut, and because it doesn't have it no longer had the stamped metal plate, we went to a magnesium plate. It got a lot lighter. So greater depth, more power, lighter machine, and also both could work on the guide rail. We also have a cordless track saw, which is in the 55 size. And we have a couple other guys here, the HK55s. Although we don't normally consider them track saws, they are still using the track. They can use the same guide rail or track that the other saws use. I also have a specialty one. This is more of our carpentry saw. You can see the blade is already exposed below. When we look at a track saw, or what's also called a plunge cut saw, the blade is inside the housing until you plunge it and make the cut. So we'll put the HK saws aside for now, and we're just going to focus on the 55 size.
And this is not all of them. 1964 was the first year we launched a track saw. So we're still missing in between this guy and this guy and this guy. We have many saws that we unfortunately don't have here. So moral of the story, Festool's been doing track saws for a very long time. And kind of the theme here as we were looking at these is they've gotten a little bit better with each generation. We find things to improve and tweak and make better. So
I like to say that the best Festool saw is the most recent Festool saw.
For sure. Yeah, and I think the next question would be then, okay, that's the history of the saws. Why would you want to use a track saw to begin with versus, say, a circular saw? Although this one is obviously a bit overkill. and there are some really good reasons for a track saw. Number one, and I think the most obvious when you see the rail systems, is to get a straight cut. You know, in the past you would have a shooting board or a straight edge or some method to try to keep the plate of the saw running up against something to make a straight cut. Well, a track saw obviously solves that because you have this rail that the saw is riding on, and you can be guaranteed if your saw is dialed in and calibrated to the rail that you are going to get a precise straight cut every single time. And that can be true over a short distance of 2 or 3 feet up to, personally, I've done a cut of 28 foot, I think was the longest cut I ever did. And I had, many rails that were linked together.
We did a 100-yard rip here once.
You guys did do a 100-yard rip once.
We connected guide rails and sawhorses and plywood.
You guys were
we could have gotten more than 100 yards.
You guys were very sunburnt that day.
Yeah, it was a tough day to be outside, but it was a lot of fun to have that continuous rip the whole way through. And like you said, you get that perfect guidance with the guide rail. I know when we first started showing this concept in the U.S., we would get a lot of comparisons to maybe using a shooting board where you have to push the saw against an edge. But here we're riding on a rail, so it's a huge difference in the way that the saw is guided, and the fact it's actually made to be guided from the beginning.
Correct. And I think this also goes to, with a track saw, and this is true with a lot of Festool equipment, but it's a philosophy of taking the tool to the work rather than taking the work through a tool. And there are many advantages to this, especially when you consider working on site where you may not have the advantage of stationary equipment, or if you have large cumbersome pieces, oftentimes it makes sense to take the tool to the job rather than take the workpiece through the machine. So those are a couple of reasons. Other things would be limited tear out. You can really eliminate tear out if you compare with a regular circular saw. There's massive advantages in the cleanliness of the cut, both on the top and bottom edge. In this case, and we might talk about this today, we can get tear out free on both the, let's say, the keeper side, but also the offcut side. So there can be applications where that is very useful. And I think those are really the main reasons to use a track saw.
I mean, why wouldn't you want a straight cut, right?
Yeah, maybe one I didn't mention as well is if you're ever cutting into a floor or you're cutting, a sink cutout, there are times where you could theoretically do it with a circular saw, but because it doesn't have really a dedicated plunge function built in, it's just not ideal.
Try to walk it in, right?
You're trying to walk it in, exactly.
Tilt it and come in and hope it doesn't
Takes
crawl.
a bit of skill, it's a bit risky, and with a track saw, you can really be very precise and intentional about where you make the cut.
As I mentioned before, the latest version is usually the best version of anything we make, particularly with the track saws. If we go back to how some of the things were done on the inside, again, this is the ATF 55, it's like 20 years old now. When I plunge it down, you see it has a riving knife, which is a really great safety feature we have on a lot of our track saws. The riving knife's job is to help keep that curve from closing in, pinching the blade, and causing something like kickback. So we have a riving knife on here, but if you look at this one, it's absolutely fixed. You cannot change it. It's in the same relationship to the blade all the time, but it comes out and it's in the way. So we actually had a little window in the back that you would take the arbor wrench and you could take the the riving knife off for a plunge cut. As we look forward into the newer versions over here, we had the TS55 EQ, a little bit older. It has the riving knife inside, as does a recent version called TS55 FEQ. If I can get my letters right, it'd be great. And how they operated was also a little bit different from the original design. So yes, they both have a riving knife. If Chris, you want to go ahead and plunge yours.
Yeah, so as you plunge, you'll notice the riving knife is coming down, but it's spring loaded. So there's actually two metal plates in here, a spring in the back, which I just unhooked, there we go. And so it would be able, like Rick mentioned, compared to the predecessor to that, if you were plunging in the middle of a workpiece for a sink cutout or in the floor, the riving knife would be able to be left on the machine as you plunge, and it would stay up in the housing.
And on the FEQ, it has a little different shape to it now, and the mechanism has changed inside, but the principle is still the same. The riving knife can always be on the machine. You don't need to remove it. In fact, I don't even have an accessible screw here to take it off like I did in the previous version. But as I'm plunging down, it'll go into where that kerf ought to be. Right now it hits solid wood, for example, until I start the saw, and then it'll track right in behind the machine, again, keeping that kerf open so you don't get the blade pinched.
Yeah, and Rick, I want to point something out. If you can zoom in on this, Chris, one difference to here you'll notice as the blade comes down, notice the riving knife is always above the bottom of the tooth right here. And on the newer saw, what you'll notice, see is how the riving knife comes down first. It's actually dropping down below the blade initially. And you might wonder, well, why is that? Well, there are times where you have a guide rail and you need to leapfrog the guide rail. Maybe you only have one guide rail, but you need to make a 12-foot cut. You can actually use the riving knife to reline your guide rail back up. Or if something happens and you ever have to go back and recut because you didn't cut all the way through, you can actually use this riving knife to reposition your guide rail so that the blade is in the exact same kerf position. And that's another feature you may not know about that is actually can be quite helpful.
In addition to the riving knife, we also wanted you to see some of the what's happening behind the blade and how we get the dust extraction we do. As you can see, this is the FEQ. This is the most recent version. The dust port has stayed intact, but I'm going to go ahead and pull it off so it looks like the EQ a couple of versions ago. And we're going to take the blades off so you can see what is behind here. So both machines featured Fast Fix, which is a patented design. This allows us to plunge a machine down. It locks the machine in that plunge position where normally when you have the plate on here, you would see that's where you can get access to the arbor nut. It also has locked out the trigger, although both of us have our tools completely unplugged, so they're de-energized 100%. It'll lock out the trigger, and it locks out the arbor too. So the blade change is really super simple. If I take this old one over here, you need about 3 hands to take that blade on and off. I could do that once, but I'm not going to try again. So we'll go ahead and pull off the blade. And now you can clearly see a huge difference here in the structure behind there. This is our dust channel. This is a dedicated dust channel. This does a couple things for us. One, it keeps the dust from going all over the place inside the plate. So that's a lot of displacement that was wasted. And also it keeps a very focused channel of flow. So yes, also on the other side, it does mate up.
Yeah, see it on the mating side. It's going to come right into that. Whereas over here, you know, you would not have had any aerodynamic flow here. It's just a big open channel, and so the dust can go all over the place, and it's much less efficient also. So you're directing the suction in a much more efficient manner with the newer machine.
In fact, if you can look in here, all around the arbor here, it's pretty clean. There's a little bit of dust. This is a used machine. This is my own personal machine, and there's quite a bit more dust. It doesn't get used on the daily, but it does get used quite a bit. And that dust has free play within that whole space, can go anywhere. Where here, it's going to be very dedicated channel. It's going to be way more efficient pickup. So now we've had a little look underneath the plate, or under the hood, as you will. Let's take a look at some of the exterior features and how they're different. So we're going to turn both of these machines around. And one of the first things you may notice is the way the depth stop looks. So on the EQ machine, it was strictly a metric scale, and it had an indicator here, and this is where you would change the depth. Just push that in, move it up and down, you can change the depth. On the FEQ, it is an imperial scale now, so it's in inches, and there's 2 parts to that. There is a part that says FS, which refers to the depth on the guide rail, which again is about 5 millimeters, or under 3/16, under a quarter inch, right? Or without the guide rail. Also, you can put a set screw on the very top of this one and adjust that and make that a micro adjustment, if you will. It's already built into the FEQ. The micro adjustment wheel is here. You can spin it by your hand or your finger, or use the Allen wrench that stores in the handle and pop that down on top, and also change the fine adjustment on the depth stop there. Another change, if you want to tilt that forward on your side.
Yep.
Is in the angle settings here. So on the newer machine, it's a much bigger scale. It's easier to read. You can see it goes from -1 all the way to 47. There is a positive stop at 0 and a positive stop at 45. We also have a delineation for 22.5 degrees. Now you can adjust that 0 degree or 90 degree position depending how you look at it. You can dial that in through the set screw here. You may also know this lever here says -1. So yes, you can back bevel this by -1 degrees. There's also a pin in the back of the machine. You can pull this out, which will allow you to also go up to the 47 degree stop. So it's a little bit more range on the angle of the bevel between the 2 machines. And again, the scales are a little bit bigger. I'm an imperial over here. I'm in metric over here.
Yeah, I think we also have a change to the splinter guard. So you'll notice on the older machine here, the splinter guard is similar to the style you still see on the TS75. It's off to the side here. You have to usually remove it in many situations. Whereas with this one, it's much more integrated. It actually tucks directly up into the housing. So if you're not using it, you'll notice the profile is the same as the housing. It also has molded into here the indicator for if you're making a plunge cut and you're at full cutting depth, that would tell you where you're going to stop your cut so that you don't go too far. So a lot of refinements in the whole splinter guard system as well.
Yeah, just to show you what that looks like, I'm going to set the plunge depth for the entire depth. I'm going to plunge this down. Oh, got to get past the splinter guard that I'm stuck on a little bit because it hasn't been cut for it. If I were to cut through that splinter guard, it would end at that line. Same thing back here, it ends the cut back here with that line. But you got to cut your splinter guard first, and I'm not cut here, so.
Absolutely. Yeah, and also just you might be wondering what is the splinter guard for? It's for the off-cut side. So the guide rail is keeping us from having tear out on the left side of the cut, and on the right side of the cut, the splinter guard would prevent tear out through the top of the surface. And if you think about your saw blade, it's spinning this direction, coming up the material this way. So the bottom edges of your cut are generally always clean anyway. It's the top that you have to be concerned about.
Yep. Now if we flip these over so you can look at the bottom where they engage the guide rail rib, the newer machine you can see a lot of wear surface here that is replaceable, and you also have these eccentric cams that hold the position very well. So once you set that tension on the guide rail the way you like it, it will hold it very well. Over here it's a little bit smaller, it's a bigger wheel. This is an older design. This is a newer design. It will last.
And these would tend to wear a little bit faster than the newer design.
You can see how much more, thinner it is here and how much more material you have on this side. So again, little improvements. We're always looking at ways to improve the performance, the function, the durability, precision of these machines over time.
Yeah, Rick, let's also show the dust port. I think that's an interesting evolution. And this also goes into a part of what I do as a product manager and going out and visiting customers is, you know, we collect feedback over the years and we may not always be able to react immediately, but as we are developing the next generation, such as the case with the track saws, we do think about, okay, what are users complaining about? And one of the things we had heard repeatedly, right now this is fairly stiff, but as these saws get old and you have a hose plugged into the dust port, and many of you watching this video that had this machine will realize this or know about this, this would inevitably turn down and get caught like this. And so as you're pushing the machine, it's really not very helpful. And so, Rick, maybe you want to talk about the newer solution that we came up with.
Yeah, we made a couple of improvements. Well, first of all, this one has a little bit of a belly right here.
Yeah, there's
so
a flare.
It's flared out, so it limits how close you can get up against the wall. So if I'm doing a relief cut on some flooring, I'm going to be further away from that wall, and I'm going to have to hide that with some molding. The newer machine, it is a more flush design here, so we can get tighter to the wall. And then also the dust port on here is articulated. You will find that it will click very nicely into place. It's also quick to remove. If I want to hook up the dust bag to it, we do have an optional dust bag you can run on here very easily, so I don't have to take the machine apart to do this. It also is with the latest hose connection that Chris has here. There are arrows and lines on here that also correspond to the arrows and lines on here. So when I put them together and I squeeze them, once it's on there, it's locked into place. So it's a very robust connection. It doesn't pop off easily. Again, you get better dust collection overall. Continuing further in this idea of evolving and changing the machines, the track saw that we started with here in the US had a stamped metal plate for the base, which was not totally uncommon for circular saws. You do have the groove that's stamped into here. You also had some relief in the plate, but it was very limited in what we could do with a stamped metal plate like that. So we did move to a magnesium plate. So Chris will tell us a little bit more about that one.
Yeah, you'll notice this this type of material we use on several machines, the Capex, our track saws, or other circular saws like the HKs. And as Rick mentioned, this is a solid magnesium plate, and there are really three distinct advantages of moving to a material like magnesium. Number one would be one you might not think of, and this is the ability to mold into the casting many different little nuanced details, such as the cams and the little plastic strips that go on the guide rail to give you that smooth surface. And all sorts of other little screws and indentations. Much easier on this than on a stamp plate. Number two would be weight savings. So magnesium, its strength to weight ratio is very good. And even compared to steel or even aluminum, magnesium is very lightweight for its size and the structure that it provides. And it also, you'll notice over here with the casting process, we're able to put webbing and other various reinforcements in here which give you a lot of additional rigidity. And then the third point would be that with steel, if you do happen to drop your saw, you can bend your steel plate, of course, and you may never really realize if it's off or dented or warped. With magnesium, not only is it very resistant to warping and breakage in general, it's very strong. If it does break, it's most likely going to fracture, and so you will actually know that it's broken because it'll be broken in half. So good or bad, at least you know it's not right. And with steel, that's not always the case. And of course, it won't rust and these types of things either. It's got that nice coating on it.
While we're doing this whole theme under the hood and what's inside these machines, I happen to have a cutaway of the TS75. It's the big brother to the TS55, but structurally basically the same machine. It does have a little bit bigger motor. It's a bigger blade, bigger depth of cut, weighs a little bit more, but they're set up internally the same way. So we have a nice little cutaway that shows the construction of our motor. But in particular, I want to share with you one of the keys to why it cuts like it does. A lot of people would ask me, hey, is it just the blades? I mean, yeah, we've got really great blades, and we're going to talk about those too. But it's not just a blade alone. You can't just put a high-performance tire on a crappy old car and expect to win the Indy 500. But if you have everything aligned perfectly inside from the engine on down, you have a winning car. So in this case, yeah, we want to talk about the motor. And in particular, I want to address the way the bearings are set up. We have a triple bearing design in here. Prior to this, and if I go back to one of those older machines we shared with you earlier, it only had 2 bearings in there, which gave it an adequate but not a particularly long life. So we found by adding a 3rd bearing to the assembly, not only was it going to last longer, but it actually helps it to run smoother and therefore cut cleaner. So that's what we're all after, is a better
increased
cut.
precision, right?
Yeah,
increased precision.
It's all those things combined. So inside there's a bearing on the end of the spindle that would drive into the arbor. There's one on the end of the motor here, and there's also one on the very end of the motor over here. So it's pretty well aligned with the triple bearing setup. We have a cutaway picture you can take a look at here and see what it looks like inside.
Yeah, and then the other thing underneath, which is a bit harder to take a look at, but the electronics. And for those of you that watched our first video, which was on the drills, similar theme here. The control board inside, it is potted, which if you remember is it's an epoxy potting, which helps with dust control, dust management, not getting into the electronics, also water, other types of vibration. So it makes the electronics very long lasting. It is variable speed, so you'll see a variable speed dial, which is somewhat ubiquitous across the various Festool products that we have. And you always, same question, why do we have variable speed? Well, we have different blades, different applications, different materials. So if I'm cutting aluminum or I'm cutting PVC or I'm cutting, whatever the material may be, there are times where I will want to run that machine at a lower speed. And so we have a dial in here that adjusts for that. One thing that is also interesting is we have what's called constant speed under load. And we actually have an image that hopefully Chris can pop up while I'm talking here. And
this sensor.
Yeah, you can also see it in this sensor here. What's happening is this sensor is measuring the rotations of the motor. I think it's 60 times per second. And what's happening is it's keeping that motor running at the same rotational speed, which is going to vary depending on the resistance, the type of materials you're cutting, your feed speed. So it's actually calculating all those different variables, and it's keeping the blade at the end of the day moving at the same speed. And what this means for you is you're going to get a more consistent, clean cut. You're going to get less wobble in the blade, less saw marks, these types of things. So it really helps with a very clean cut. A couple other things, the electronics, overload protection. It's pretty common, but it is built in. So if the motor overheats, it is going to shut itself down. You also have a soft start, so when you pull the trigger, it doesn't just go up to 100% right away. It ramps up slowly, which is nice from a safety perspective and also just an ergonomic perspective. And I think that's
yeah, if you ever trigger like the overcurrent protection or the overheating protection, it can recover on its own. You don't have to send in for service. It just needs to cool off essentially, and it'll be reset and ready to go again.
That's right. And really all of this around electronics, yes, it is about performance, but I think more importantly, from the potting to the overload protection, it's to protect the machine from failure, to reduce downtime, and ultimately that's what it's all about, increasing the longevity of the machine.
So we spent a lot of time taking a look on the inside of the machine, and there's a lot of cool stuff that helps it perform the way that it does. But the most important thing is where it makes contact with the wood. So next we're going to talk about the circular saw blades. Now you have to understand that when you take this much time and a history, we talk about the evolution of these saws, to develop the machine to what it is today, you just can't rely on off-the-shelf solutions. We needed to have saw blades that were absolutely engineered and designed to maximize performance of the machine and produce the best quality cuts. So with the TS55 FEQ, we have now our latest generation of saw blades. They are a thinner kerf than what we've had in the past, but we have found that we have a thinner kerf blade that holds true. It gives us a clean cut. It doesn't bind, it doesn't burn, it doesn't pinch.
Doesn't deflect.
Doesn't deflect, and it lasts longer. It is a more durable blade than we've had in the past. So that's saying a lot. It's a huge leap for us. So the machine is now equipped with a 42 tooth blade. I'm going to go ahead and use that fast fix to lock it down for the time being. It's a 42 tooth blade. It is carbide tipped. We use an alternate top bevel blade for most of our wood cutting blades. So 42 tooth blade is great for most sheet goods. You can cross cut with it. It's okay for ripping, I would say, but we have other options for ripping, especially if we're going to rip solid lumber. So on my little board here, we have some of the other blades for wood. I know they're for wood because we use a little color code. It's yellow on the inside, and for those of us who can read it, it says wood. That helps a lot. So this is going to be our what we call universal blade. This is a 28 tooth blade, and by universal, we're going to be able to both rip and cross cut with it. Is it great at either one? Not particularly. It's in the middle. This is a compromise, if you will. But it's actually one of my favorite blades because I can leave it on the machine most of the time and do what I need to do. I mean, as cool as Fast Fix is and as easy it is to change a blade, I'm human. I might be a little bit lazy sometimes, and I just want to grab it and go. I got to get something cut. 28 tooth is a great choice for that. However, if I'm getting into some heavy lumber, I'm going to do some dedicated ripping, I'm going to go with a ripping blade. So this one has 12 teeth. And if you remember, when you have fewer teeth in the material, fewer teeth at the push, the less the load is on the motor. So this allows me to take on those bigger, heavier cuts.
Also jump in, Rick.
Yep.
You'll notice as we go from the 42 to the 28 to the 12, the gullets, which are these little recesses here, they get deeper and deeper. So generally speaking, as you have fewer teeth, you have deeper gullets. You're taking a bigger bite of the material each time.
A bigger chip.
Bigger chip, essentially. And so you have to have room to grab that chip and eject it out of the kerf as you're cutting. So sorry to interrupt you.
No, that's great. That's a really good point about tooling in general, is you got to have the ability to clear your chips, otherwise you don't have dust extraction going on very much. You can also see some relief cuts in here to accommodate for if the plate starts to heat up, it can expand and go somewhere and it doesn't warp. So again, we don't get that burning that you normally see in a cut, but it keeps that plate flat and running true. Some other options we have in the red, I know this one's from plastics. It says laminate on it as well. It has another brand of Trespa, which is a paneling material we don't normally see in North America. But this is going to be a very high tooth count on this one. This is a 52 tooth. And now we're going to move away from the wood geometry, the alternate top bevel style, or modified alternate top bevel, to a triple chip design. So triple chip is the way the top of the tooth is structured. It's a very durable tooth design. It's great for things that aren't wood. Next up, we're going to move over to another 52 tooth blade. It is a modified triple chip in a way, and this one is for aluminum and plastic. So you can use both of these in plastics, but this one says specifically plastics and aluminum. The key difference between the two of these guys is going to be in the angle on the top of the teeth and how that's ground, and also the angle of the tooth itself. So generally with a wood cutting blade, you see a more aggressive angle. If you look at this rip blade, those teeth are pointing forward, they're angled forward. And when you get to something for plastics, aluminums, metals, it's going to be a 0 degree rake normally. Miter saw, you would actually see a negative rake on that. And the last one here is a bit of a specialist. It says for building materials or abrasive materials. So basically your cementatious paneling. So whether it's for underlayment or siding.
Duroc, fiber cement products, Hardy Backer or Hardy Board, these types of things.
There's a lot of brand names available out there. This is going to go from where these are all carbide. This is a polycrystalline diamond tipped blade. And you can see the gullets are a little bit different. It's a continuous outside, but the teeth, there's only 4. So it's a really low resistance, very fast cutting blade.
And I would add to that one, Rick, you know, that would even be appropriate for some drywall cutting applications. So obviously commercial drywall are probably not going to use a track saw for cutting, but there are times where if you don't want to cut all the way through the drywall and you're trying to wrap something, or you have special situations, taper columns, it could be useful to use a drywall or a track saw for that application. That would be the blade for that.
So if you're considering either upgrading or getting your first Festool track saw, keep in mind that we do have 6 different blades for different applications. You're going to get different cut results because it's made for so many different things.
Yeah, and just one last point, a little bit of a soapbox here. You'll notice, and if you compare it to other blades on the market, not all blades have the same thickness of carbide front to back. And so what I would always encourage people to do is, if you have these blades, if you buy the additional blades and your blade gets dull, first tip would be clean the blade. 9 times out of 10, I've had multiple sharpening companies tell me this. They get blades in that are actually still sharp, just dirty. So keep a clean blade. That would be one important tip. And the second thing is, don't throw the blades away. When they get dull, get them resharpened. All the measurements that your sharpening service company will need, they'll likely be familiar with Festool blades, but they're on the blade itself. And most companies that have modern sharpening equipment can sharpen these blades. And you can usually get 5, 6, 7, sometimes 10 sharpenings out of a single blade. And yes, you're going to pay $20, $25 to have the blade resharpened, but that's about a third or fourth the price of buying new blades. So that's a great way to just reduce your cost of ownership and your cost to operate the machines, is get your blades resharpened and keep them clean.
The last point I want to make about the blades, again, that kind of makes them special. is the bore size. So if you're familiar at all with them, the bore on this is 20 millimeter. If we look at that TS75, it's a 30 millimeter bore, and it's like, wow, why did Festool make it a weird size? Why isn't it just a 5/8? There's a couple of good reasons for that. Number one, 20 millimeter is very common globally. We're like the only country that this isn't something you would see everywhere. But also, if we think about it strictly from the physics point of view or leverage point of view, is if this blade, if this is a lever from here to here, it has a much larger fulcrum, and there's a lot less leverage. So you get less deflection in the plate. Again, this all translates back to cut quality. We don't want the blade to deflect. We don't want it to burn. We don't want it to bind. And we just want the cleanest. And I like to say our first cut is the finished cut with a Festool saw blade.
So we've talked a lot today about the machine and the saw blades, and while those are all very important things, the guide rail is also very important. So this is actually our second generation guide rail. It's been out for quite a number of years now. The original was just FS. This is FS/2. One thing on this guide rail is the splinter guard. This has been something we've worked on over the years. Way back when, there was a black splinter guard. And then at some point along the way, we went to this clear splinter guard. Now, one difference to what's commonly seen on the market, most of them out there are a rubber material, which is relatively soft. This is actually an extruded plastic material, which is very hard. And it keeps a very crisp, sharp edge when you cut through it. It's also translucent, or clear, I guess I should say, clear, opaque material. This gives you a nice contrast to your pencil lines. So when you are lining it up, you can see exactly how to split that line or be just inside the line, whatever you prefer. Another thing a lot of people don't know is we've designed the adhesive so that you can peel it off and reposition it, so that if you want to move it over and get another cut, you can do that. Well, hopefully all of this information we've shared today gives you a perspective on the history of track saws with Festool, why you should consider using a track saw, a little bit of a look into the evolution of our track saws, and I think you can see that the brand Festool is somewhat synonymous with track saws. We've been doing track saws for over 50 years, thinking about track saws as a company, how to improve track saws, continuously improving the design and engineering. And as you can see, there's a lot of things that are going on with this machine. So,
thanks for watching. We appreciate you tuning in to Inside Festool, and we'll see you next time.
Thank you.